briefly, I want to remind us of two characteristics of functions, and then we'll return to curve sketching from tables. So we have two characterizations for functions. Even, which means that when we plug in the opposite value of x, we get the same y value. What this means is we're symmetrical. About the y-axis. So what does that look like? Well, it looks a little something like this. Right? I could reflect this graph over the y-axis and it would land on itself. If I put in -2, I get the same y value as if I put in +2. Then we have odd, which has the opposite sign when you plug in the opposite value. So what does that mean? Well, that's going to be symmetric. Why can't I spell? About the origin. So for this, we're thinking about functions that look like this, right? So if I've got 1 gives me -1, I'm sorry, 1 gives me +1, and -1 gives me -1, right? F of 1 is 1, and f of -1 gives me the opposite, -1. I shouldn't have put an equal sign here. Should have put an and. No, I was right. Sorry. So if we did the opposite of f of -1, that would be +1, which would be equal to f of 1. So this function is odd. The reason we did that is because even functions comes up in this first problem as well as several other open-ended problems. So we're given a lot of information about the original function f, its derivative, and its second derivative. In each of these spots, we are told different pieces. So here, this first part, when x is 0, we're told f of x is 5. So we know we've got the point 0, 5 on our graph. So let's label this guy. So we can go ahead and put that on our graph. And we're told that the derivative is 0 there. So we know it's going to be flat right there. And our second derivative is negative. So that's going to tell us concave down. I need a thinner marker. Bear with me. Okay. So we're concave down here. So we've got a shape like that. That makes that a relative max, but so we'll say. All right, then we're told that at 1, we've got the point 2, right? That's what this means here. So at 1, we've got the point 2. Let's label these guys just for clarity's sake. All right, so we're concave down and we go down to 2 at 1. All right, and then between 0 and 1, our y values are positive, which we've got here. Our second derivative is negative, and our first derivative is negative. So this would mean decreasing and concave down, both characteristics that we have. All right. Our second derivative is 0 at this point, so we've got a possible inflection, and since it changes to positive, this is an inflection. So our concave down is going to change to concave up at that point. And we are negative, so we're still decreasing, and we're still decreasing afterward, we know that our y values are going to continue to be positive. So we're switching to decreasing and concave up. Right. Until we get to 3, and I'll add another piece of information here for us. We'll say when x is 3, we've got a value of 0. Right. So concave up, decreasing, and remains positive. Since it's even, we're going to be symmetric. So we've got kind of a bell shape going on. All right, so that's our first problem. So go ahead and write that down.